Hello friends, welcome to engineering tutorial. So in the previous video we discussed the basic time shifting operations directly performed on a basic test signals, that is the unit step, ramp and impulse signal. In this video we are going to perform some time shifting operations on some random signals with different shapes and will perform time shifting operations. So here we have this M shaped signal, okay, xt, and we have to perform the time shifting operations. Okay, so let us first do this operation. Let's say x t minus 3, okay, sorry, xt plus 3, okay, first let's do plus and then we'll do minus. Okay, so here the sign convention, if we want to perform the shifting operation directly, we have to follow the sign convention. I have already told you, when we see this kind of an expression, time shifted expression, the plus sign, it means that the shifting will take place to the left, and the value after the sign, it gives us by how many units the shifting will take place. So here the shifting will take place to the left by 3 units. Okay, so here what we have to do is, okay, plus means left by 3 units, plus 3. So here what we have to do, we have to pick the starting point and the ending point of the signal. Here the signal exists, this M shaped signal exists between 1 and 3. These are the 2 points. It is the starting point, it is the ending point. Now as this signal xt plus 3 will shift to the left, okay, to the left by 3 units, what we have to do is that we'll subtract 3 from 1 and here 3 from 3. Okay, so this will give us the new starting point and the new ending point of the shifted signal, which is -2 and 0. So the new shifted signal, it will start from -2 and it will end at 0, but the shape will stay the same. Okay, -2, 0. So let us see how this shifted signal will look like. So here clear, you pick the starting and ending points of the signal which is given xt. Depending on the shifting, plus 3, plus means to the left by 3 units, we subtract 3 from the starting point 1 and the ending point 3, which gives us the new starting point and ending point of the shifted signal. So the shifted signal, it will look something like this. X t plus 3, 0, -1, -2. Okay, so it will start at -2 and end at 0. This is the shifted signal. This also exists here. Okay, now everything remains the same, the shape of the signal, the amplitude of the signal, everything will stay intact. Only the starting and ending points of the signal will change because of the shifting from -2 and ending at 0. Here it was from 1 to 3, here it is from -2 to 0. So this is the time shifting operation. Now let us do in the other direction. Okay, so now let us perform the shifting in the other direction. Let's say x t minus 1. So here again the sign convention, minus means the shifting will take place in the right side, towards right, by this number, it means by 1 unit. So again we will use the same approach. We will take the starting and the ending points of the signal, which are 1 and 3. We will add 1 to this starting point, which is 1 plus 1, which is 2, which is the new starting point of the signal. And we will take the ending point 3 and also add 1 to it, which will give us 4, which is the new ending point of the shifted signal. So this is the new starting point and this is the new ending point, 2 and 4. Okay, so let us do the shifting. Okay, so here the new starting point, the new ending point. Okay, so this is the shifted signal x t minus 1. It has shifted to the right by 1 unit. Okay, by 1 unit it has shifted to the right. So this is the time shifting operation performed on this signal in both directions. Okay. Okay, so here we have another signal xt. Here we also have to perform the shifting operations. Okay, so let us perform the shifting operation x t plus 3 on this signal. So again the same approach. So first, sign convention, plus means shifting will take place to the left by the value which is given, the number value, by 3 units. So again what we have to do, you pick the starting and the ending points of this signal, -1 and 2. Then you subtract 3 from both the starting and the ending points. So -1 minus 3, -4 is the new starting point, and 2 minus 3, which is -1, is the new ending point. Okay, so -4 and -1. So the shape of the signal will stay the same, it will remain intact, the amplitude the same, all the same, but just the starting and the ending point will change. So let us do the shifting. So it is all in the negative axis. So this is xt plus 3, 0. So it's -1, -2, -3, -4. This is 1, 2, 3. Okay, so the signal will be like this. So from -4, the starting point will exactly be the same. Okay, then 3, yes, then downwards, and then it will touch this. Okay, so the signal has shifted to the left by 3 units. So this is the shifted signal. Everything stays the same, the values, the amplitude, everything, just it has shifted to the left by 3 units with new starting and ending points. So this is the whole approach. Now let us do the other thing in the other direction. Okay, so now let us do the shifting like this, x t minus 2. Okay, so minus sign means the shifting will take place in the right side towards right, and 2 means by 2 units. So here again you pick the starting and the ending points of the reference signal, the original signal, and will add 2 to it. Minus 1 plus 2 which will equal to 1, which is the new starting point, and 2 plus 2, the ending point we add 2 also, just 4, which is the new ending point. So 1 and 4. Okay, so now let us perform the shifting. So it is all on the positive axis, 1 and 4. So 0 t x t minus 2, 1, 2, 3. Okay, so 1, 2, 3, 4. So we'll start from 1. So it is this, like this, 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 here. Okay, so this is the shifting in the right side by 2 units. So the new starting point 1, new ending point 4. All the remaining things, they are the same. The shape, the amplitude, everything, it stays the same. Just the starting and the ending points have changed. Okay, so here we have performed the shifting operations on some basic signals and some random signals. I just wanted to acquaint you with the direct method, where we don't have to use a new signal yt and equate it with this shifted signal, because that's very lengthy. So you should be able to do this direct shifting just by looking at the expression. So always use this method for examinations, because there is a time crunch there. So practice more and more with more and more signals, more and more questions, and then you will get a you will fall into that habit. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.